Hello, my name is Vlad, and with this video I'd like to briefly introduce the Tilck project in a very informal way by showing what the Tilck kernel is currently capable of without entering in technical details at all. It will be more like a show than a technical talk. Before beginning, let me just mention that the Tilck project does not consist of just a kernel, as you can see in this picture. There's plenty of other stuff, but in this video I won't deep dive in any of these details. Now, let's boot Tilck. As you can see, the bootloader supports both text mode and graphical mode. Let's choose graphical mode. Here we are, the Tilck kernel booted very quickly. As you can see, we are running in the AS shell. We can do, this is one of the several BusyBox applets that are supported here on Tilck, as you can see in bin the symlinks. We can do pretty much of the typical stuff we can do on other Unix systems, like pipes work, redirects work, as you see. Now, since we are in a graphical mode, we can expect, at least on Linux, we can expect to exist an FB0 character device in dev and to be usable. Of course, that happens in Tilck as well. So the cool thing is that user applications can use it. For example, this application here, it's a nice Tetris game I wrote about a year and a half ago because of Tilck, of course. But first I wrote a tiny frame buffer library for Linux and Tilck. It's actually exactly the same. And then I wrote this game and other applications, but the whole point was to kind of see what can run on Tilck, stress it, and believe me, this application stressed me and the kernel. It required the kernel to support FPU, any kind of bugs like in context switching, whatever. A lot of this game allowed me to reproduce a lot of problems in the kernel, helped me stabilize it a lot. And that was a year and a half ago, considering now how many things have changed. And a year and a half ago Tilck was unable to do anything, but yeah, still was able to run this. It uses here a non-blocking read, so pretty much of stuff is going on. But this is like cheating, showing you this because it's a small application written by me, keeping in mind Tilck, and so I haven't used all the syscalls possible. It was just using non-blocking read because at the time that was available. There was no select, no poll. Now Tilck include these syscalls as well. So let me show you something much cooler, like the port for the Linux frame buffer of Doom. It's an open source project and it's pretty cool. And it runs on Tilck smoothly. Of course, there is no sound because Tilck has no sound drivers, but yeah, it runs really, really well. It required some effort, the way time flows. It required some fixes of get time of day, but yeah, it works. It wasn't even the hardest thing to make work on Tilck. Generally, I just compile for x86 the given application with libmuzzle, and then I run a Tilck and I debug it. I debug my kernel, of course, because the whole point is assuming that the application is good. If it runs on Linux, it's fine, and it has to work on Tilck exactly the same way. I just wanted to mention out this is a debug mode. Debug mode means O0 and means also -f no-inline functions. It's much easier for me to debug, and this is the slowest build of Tilck possible. This is what I use for development. It's like 3-4 times slower than the the release build, and still, I mean, you see no lag. I mean, it works really, really well here. There are a lot of stuff going on to have Doom running, but it isn't even the hardest program that I made to work on this kernel. Let me show you one thing that will lead to another application. Here you see Tilck console have multiple support multiple virtual consoles. I mean, scroll works, things like that. But this is basic stuff. This is just an introduction to show you the cool thing. What can be cooler on a console? Well, to run a powerful console application. What's more powerful than a powerful editor? Well, yeah, it was been like a goal since I started thinking about Tilck. I said it would be fantastic to run Vim, and yes, I was able to make it run with syntax highlighting, everything with Vim's runtime scripts, everything. It runs, but it was a nightmare. Really, it was a nightmare to make it work. It required a lot of debugging, but yeah, it works. I mean, whatever you can do visual mode. You can do whatever you do. I don't have time enough for show you Vim features, but it works correctly. And it requires implementing like 90% or more of the escape sequences supported by the Linux kernel, unfortunately. While running Ash was relatively much simpler. Even running VI, which is an applet of BusyBoxes, it was much simpler. I mean, there is no comparison between VI and Vim. Anyway, now let's move on to another interesting program. Now we saw that we can run Ash scripts. For example, the start script. I showed several times, but I wanted to remark that this is an Ash script, and I mean, whatever you can do, fine, write scripts and they work. But wouldn't it be cool to even like write a C program using Vim and compile it on Tilck? Yeah, it's possible. It's possible. I made work the TinyCC compiler, which is a small compiler written by Fabrice Bellard, but it's I mean, making work GCC would be, I mean, GCC is a monster. You can imagine that it will probably require to make glibc to work and a ton of other stuff, and I don't even thought about trying this. I mean, it's an overkill for a small kernel like mine. So I found this compiler that is able anyway to compile the Linux kernel. It was able from the beginning, so it's a fair compiler, I'd say. For example, let me show you how we can compile a simple Hello World application. Just the only thing, it's necessary to compile with static linking, because Tilck does not support dynamic linking at the moment. As you see, we have 20K of the application. It works. We compiled it fine. The other applications work as well. Now let's move on to a developer-only feature, but it's cool to show. It will be even cooler in a moment. It's called the debug panel. It's a module, of course. As you can see here, there are several modules, and if you wanna, I mean, in embedded, in case this project reaches really embedded environments, of course, all this can be easily stripped down. These models can be compiled out, and I don't have now time to show you, but I can create a super small image of Tilck. But in case you're developing it, it's fine to have much more stuff, like this debug panel, which is actually not that heavy, but it's cool that it can be compiled out. You can see here some compile options, some runtime stuff, the physical memory map of the machine, the heaps of the memory allocator, the list of tasks with their bit, their JIT, their SID, so the session ID, process group ID, their parent ID, and their current state, their TTY, other heavy statistics about the chunks, memory chunks allocated, a lot of interesting stuff. But this will get more interesting in a second, because the Tilck console support also serial console, so you can have not only video consoles, as in this case we have here 2 video consoles, but you will have also a serial console, actually a number of serial consoles, but the point is having at least one, and we can connect with screen. Every 3 seconds there is a message that is printed, which is the same, so just not the dev TTY S0. So now we are connected to Tilck, but with a serial console. The cool thing is that now we can open the debug panel here and do this. Go to task and select a task. For example, this bit 73 is this shell here. It runs on TTY1, and we have to mark it as tracing, and then go here. Okay, now if we press enter, tracing is active, and whatever happens here, you see here. I mean, it follows also the children, so you can, I mean, whatever you can do, whatever. I mean, imagine du what does. I mean, it works really fine. It was useful for me to debug Vim, and you can for example specify it has it has a nice feature allowing you to edit expressions, like I'd like just to see the read calls, and yeah, here you are. It will just trace read link, read v, etc. So now, as you see, that's it. So I hope it was fun, and yeah, I have to finish. Just I want to show you one more thing, which is the Tilck building booting on EFI. That's it. It's the same thing, just it boots on EFI. This is a complete different bootloader, and it works as well. So I hope it was fun for you, and I hope you enjoyed the video. Bye.